Do you know that in nature there are some elements which exist in different forms? What are these called? These different forms of elements have different physical properties and they perform different chemical reactions. Hello, friends, I am Siddhi and I welcome you. In this video, I will give answers of these questions and will explain about it in detail. So, answer of the questions asked in the beginning of this video is allotrope. Why and how do allotropes form? What are the reasons of forming different forms of an element of different properties? Let's know that what happens in nature that results in the formation of allotropes of some elements. The conditions like pressure, light, and temperature are different at the time of formation of the element, which gives rise to different forms. The different forms of elements are known as allotropes. These allotropes exist in different physical states which are chemically same. The property of the existence of an element in more than one form having the same chemical properties but different physical properties is called allotropy. So, in this video, you will learn about allotropes of carbon. Basically, carbon exists in two main allotropic forms, crystalline form and amorphous form. Crystalline forms. A crystalline form has a long range of ordered molecules and a sharp melting point. Diamond, graphite, fullerene, carbon nanotubes are examples. Different types of allotropes of carbon can be represented and understood by this flowchart. So, for the first is diamond. It is the purest crystalline allotrope of carbon. It has a number of carbons linked together tetrahedrally. Each tetrahedral unit consists of carbon bonded to four carbon atoms, which are in turn bonded to other carbons. This network of unstrained covalent bonds make diamond extremely strong, and so, diamond is the hardest naturally occurring material known. It has the highest thermal conductivity and it is an electrical insulator. Everyone knows a very popular use of diamond. Yes, you are thinking right. That is in jewelry due to their shiny luster and their durability. Diamond has properties like hardness, abrasion, transparent, resistance to heat, and so it is used in industries, engraving, audio equipment, beauty products, and heat sinks. More sophisticated uses for nanodiamonds in high tech applications, including super lasers, surgical tools, medical devices, and next generation computing. Now, next is graphite. It is also a crystalline allotrope of carbon. It has a unique honeycomb layered structure. Each layer is composed of planar hexagonal rings of carbon atoms in which carbon carbon bond length within the layer is 141.5 picometers. Out of four carbon atoms, three forms sigma bonds, whereas the fourth forms pi bond. One of the most prominent properties of graphite is it is a good conductor of electricity due to free flowing electrons. Each of the carbon atoms in graphite is in a state of sp2 hybridization, whereas in diamond, each carbon atom is in sp3 hybridization state. Graphite is used in writing materials like pencils, lubricants, refractory, nuclear reactors, batteries, and graphene sheets. Graphite occurs in metamorphic rocks as a result of the reduction of sedimentary carbon compounds during metamorphism. It also occurs in igneous rocks and in meteorites. Minerals associated with graphite include quartz, calcite, micas, and tourmaline. Do you know the material which has properties of both metal and non-metal? Yes, the material is graphite. Why graphite is unique? Which property makes it unique? So, graphite is unique in that it has properties of both metal and a non-metal. It is flexible but not elastic. It has a high thermal and electrical conductivity and is highly refractory and chemically inert. This structure is just like a cage. What's this? This is an allotrope of carbon. Besides of diamond and graphite, one more crystalline allotrope of carbon is there, and that is fullerene. So let's learn in detail of fullerene. A fullerene is an crystalline allotrope of carbon whose molecule consists of carbon atoms connected by single and double bonds so as to form a closed or partially closed mesh with fused rings of 5 to 7 atoms. The molecule may be a hollow, sphere, ellipsoid, tube, or many other shapes and sizes. Friends, do you know that fullerene is also an unique allotrope? So let's know that why it is unique. The fullerene structure is unique in that the molecule is borderless, uncharged, has no boundaries, no dangling bonds, and no unpaired electrons. These characteristics distinguish fullerene from other crystal structures such as graphite or diamond, which have edges with dangling bonds and electrical charges. Now I will tell you about the uses of fullerene. The major advantage of using fullerenes as medical antioxidant. Fullerenes are used in the medical field as light activated antimicrobial agents. It is also used in several biomedical applications, including the design of high performance MRI contrast agents, X ray imaging contrast agents, photodynamic therapy, and drug and gene delivery. Hope you like this video. My next video will be on amorphous allotropes of carbon. Please subscribe, like, share, and comment. Thank you and take care.